So first, the plan. We are in week 15. Next week is finals week. I would like to do more notes today, Wednesday, and then we should review Thursday, Friday. So, we're going to do 5.4 today. I hope to get through as much as 5.5 as I can. And then we review for the test. And your final test is kind of like a take-home test where you'll do it online. We'll do it on WebAssign. And you'll have it available this Thursday and due next week on Friday. That would be the 13th. Let's see. This Thursday is the 13th and due on the 21st. So let's start 5.4. Oh, also, I will make exercises for chapter 5, but they're not going to be part of your grade. So it's going to be practice. And there's probably going to be at least one, maybe two questions from chapter 5 on the final. Okay. Now, 5.4 is about indefinite integrals. Indefinite. Cool. So we've got a definite integral we've already gone over before. We'll restate this one. So for a definite integral, you integrate from a to b. Your function, we'll call it f of x, and integrate with respect to x. So we say dx. Find the antiderivative of this function, which we're going to call capital F, and put in b, and then subtract capital F of a. One more time, that capital F is that antiderivative of the lowercase f. capital F is any antiderivative of lowercase f. So for the indefinite integral, you have a continuous, let's see, any function representing, they don't need it. Check the book. I want to check if f needs any certain requirements. I don't see anything. Okay, I'm just gonna go straight in there. Straight to it. All right, for a indefinite integral. We have just this symbol, the integral sign. And it's the integral of f of x dx equal to capital F of x. And what this means is that f prime of that function will be equal to the lowercase f of x. Examples. So, first one, you have an indefinite integral of the sine of x plus 5x plus 2. Here, it's like, just put find. Sine of x, add 5x. Plus 2 dx. Okay, so the antiderivative of sine. Negative cosine of x. So just you can check by taking the derivative term by term as we go and make sure that you get back to this function in here. So derivative of cosine is negative sine, and that other negative would get you back to the positive sine of x. Add 5 times x with power 2 over 2. Add 2x, and then plus c, some number c. And that's it. Oh, I forgot. Let's see this part here. Oh, never mind. I rewrote the problem. So in my example, I had 5 to power x, but 5x does give you this as an antiderivative. Let's do that one on the side then. Let's do this guy. Separate. Okay, so we have 5x over ln of 5 plus c. You can check by taking the derivative of this and make sure you get back to 5x. So the derivative of 5 to the x over ln of 5. Oh, do scratch work. Quick check. 1 second. Okay, I know we had this in a table before, but still, couldn't hurt to do some practice scratch work. So this is just some number which stays there when you take the derivative. This is the value where the derivative of 5 to the x, 5 to the x times ln of 5. Derivative of a number is 0. So that ln of 5 over ln of 5 reduces to 1, and you've got just 5x at the end. Okay, next one. Number 2. This is the integral of d squared minus 3t plus 5 over root t. dt. So integrating with respect to that variable, which is t. All we're going to do right now is rewrite this piece in here. So t to a 1/2 power is down below t squared minus 3t plus 5 dt. Okay, so it's going to be t to a power of 2 minus 1/2. Subtract 3 with a power of t with a power of 1 minus 1/2. We'll have 5 times t to the negative 1/2. So there's going to be 3 halves, 1/2, negative 1/2 as our exponents. And let's see this for a minute. Okay. So what we do is add 1 to the power and then divide by that number when you get an antiderivative. So 3 plus 2 is 5, so the power is 5 halves. And then divide by that number, that power. Okay. Minus 3 times t to the power of 3 halves, and then divide by 3 halves. And this one, when you add 1 to that power, the exponent is going to be positive 1/2. And we always add c at the end because there's possibly some number that when you take the derivative of this piece, you'll come back here and have that plus 0 at the end. So we have plus c at the end of these indefinite integrals every time. So actually, we can write this a bit better. Cool. Let's do 2/5 t to the 5 halves minus, this is going to give you multiply by 2 over 3. The 3's cancel. We have 2t. 5 stays there. Plus c. That's over. Okay, we're going to do the indefinite integral of the sine of 2x over sine of x dx. Piece, right? Better, sort of. Okay, first, what we're going to do is use a trig identity on what's in the numerator. I just rewrite the integral a little bit. It's going to be, let's see, 2 sine of x cosine of x is the identity I chose. So we're going to integrate 2 cosine of x. I can bring any number value in front of the integral sign if I want to. I'd like to have that 2 out front, my cosine of x dx. And the integral. And let's do this. So, I've got 2 times the integral of the cosine of x to be negative sine of x plus c. And c is any number at all, so we're going to put 2 times negative sine of x plus c. You can have that 2 times c, but we don't know what c is anyway, so we're just going to have it on the end. And rewrite this up a little bit better. Actually, I don't have a negative sign of c. Double check. The derivative of sine would be cosine, so I don't need this. Let's do it again. The derivative of this should get me back here, which is that spot there. Derivative of 2 sine of x would be 2 cosine of x. Good. And the derivative of a number is going to be plus 0. That's better. Let's do a table of integrals. Okay. So first one, let k be some constant. So k is a number. Okay, first one, the integral of k with respect to x. Is going to be kx plus c. That number times the variable x add some other number, we call it c. Right. The integral of x to a power n dx is going to be x to the n plus 1 divided by n plus 1, then plus c. And then just a side note, n is not equal to negative 1. Okay. And we're going to do the integral of e to the x dx. Let's do 1, 2. E to the x plus c. Integral of 1 over x dx is ln absolute value of x plus c. So I feel like the absolute value part is important. Sometimes when I look up work on like Google, there's parentheses, but in the book, it would be an absolute value of x. And then add some number, c. Okay, let's just keep on with it. Number 5. Indefinite integral of a to the x dx. Some number a with the power x. It's a to the x divided by ln of a and then plus c. Number 6. The integral of sine of x dx. It is negative cosine of x plus c. Number 7 is the integral of cosine of x dx. It's going to be positive sine of x plus c. We are at the integral of secant squared of x dx. It's going to be tangent of x. Plus c. Just kind of using all of the derivatives that we've learned to make a table of antiderivatives. So if you remember, the derivative of sine, the derivative of sine is cosine. The derivative of tangent is secant squared. And going from secant squared to tangent was getting an antiderivative. Going from cosine to sine is getting the antiderivative. Okay, let's integrate. Let's get to 1 over 1 plus x squared dx. So, kind of particular problem. It's equal to tan inverse of x plus c. Let's do the integral of sinh of x and cos of x. After that, we'll try some examples or something. So we can antiderivative to get to cos of x plus c. And that's going to give you that sinh of x plus c. Cool. And then I think this would be a good place to just try some integrals, some indefinite integrals. What do we got? Let's do. Instead of using book problems, I'm going to find old notes. So just a sec. Okay. Yeah. So, integral of, it's amazing. Cool. Let's do sine of x plus 7. I think we haven't done that before. Okay. So we take that first term, get the antiderivative, just go term by term, and then add c at the end. So we just did this. Sine has an integral of negative cosine. X will be raised to a power of 2 and then divided by 2. And 7 multiplied by x and add c. Okay, we did that. We did something like that. More notes. Okay, so just trying to get us ready for Wednesday, which we want to cover, which is the day where we cover U subs, and then might even just start to introduce that. try to just introduce you subs, and that way when we meet next time, we can start practicing and do a lot of examples. So let's change sections. Yay, we made the goal. So we're at 5.5, which was what I was hoping for us this semester. So U subs, or U substitution. If f is continuous and g of x is equal to u. Then the integral of f of g of x times g prime of x dx is equal to the integral of f of u du. So we're going to have a function inside of a function. That inner function we will call u. And then we will do the integral with respect to u. Then at the very end, come back to having that variable x as your only variable in your answer. Okay, so we've got that you want to use this for composition of functions, a product of functions, or if you don't have any other ideas, try substitution. All right, so let's see. I've got steps. So I think we can do the steps and then try to do one example. So we will let u be a function of x. Or whatever variable that you want to integrate with respect to. Number 2, solve for x and dx in terms of u and du. Number 3, convert the integral to u variable form. after integrating, rewrite the antiderivative as a function of x, or whatever variable that you started with. As a function of x. Last step, check your answer, if you have time, by finding the derivative. And we'll do just one for today. So we want to take the integral of the cubed root of 1 minus 5x. Oh, it's a cubed root. Okay, and after doing a lot of these problems, I've looked for letting u be anything underneath a root, or u is usually something maybe in the denominator. But you can try different values for u and just see what works. You're just trying to do some kind of substitution that makes the problem easier to work with. Okay, so I'm going to go ahead and just try or let u be 1 minus 5x. Doing a derivative right now. Derivative of 1 is 0, and we've got derivative of negative 5x. Negative 5. Okay, multiply both sides by dx. Actually, I like to just go ahead and solve for dx and replace this dx with whatever scratch work I've done here. So I would divide both sides by negative 5. Dx equal to negative du over 5. Okay, so I'm going to replace this dx with that dx. And I'm going to replace 1 minus 5x with u. Okay. Let's do it. So I've got an integral of the cubed root of u times negative du over 5. Yeah, so I've taken away this piece. My dx is right here. It's in terms of what did we say? How did we say? We solved for x and dx in terms of u and du. So dx in terms of du. Okay, so I can bring that negative out front. I'm going to bring the 1/5 in the front. And then have my integral sign, the cubed root u. Oh, there's my du, right in there. Du. So plus u to a power of 1/3. du. When we integrate, we add 1 to the power and then divide by that number. So we're going to have 4/3 and then divide by 4/3. -1/5 sits up front. And the integral will be u to the 4/3 over 4/3 plus c. Okay, so we want to simplify these fractions. We also want to replace u with what we had it equal to earlier. That way my answer is in terms of x. So last step is negative 1/5 times 3/4. Then u is 1 minus 5x. And it has a power of 4/3. And plus some number at the end. Okay, I think that's good for today. We will meet on Wednesday, do a lot of examples for U subs, and then that's it for all of the material that we needed to cover this semester. Thank you. I will see you at the next meeting.